All right.
Did you get the marks on here?
So.
They're gone, like, but someone's still over.
All right. So first here, we're gonna do a couple different things just so you get a sense for how this thing works. So first thing here. Here's what I'd like you to type in. Let's go with. This can be my function y equals, and let's type in x cubed. Okay. So here's the x cubed graph. Okay, if you hit enter, it'll just draw it. This is the default graph for a cubic graph. How we know that? If it's an odd power, the tail's going in opposite directions. Even powers, the tail's finishing in the same direction. Okay, so what we're doing here is we're going to mess with this graph in different ways. We're going to walk through the different types of transformations. Here's the different types of transformations we should know. Right? Horizontal shifting, the stretch or shrink, reflecting, and vertical shifting. So we're going to walk through each of these four types so that you know how it works. Okay, so you understand what it's going to look like when I look at a problem. So for instance, if I want to horizontally shift this thing, what you do, so I'm going to type this in a new graph, y equals, now in parentheses, I'm going to type in, like x minus 5. And what this should do is it should shift my graph to 5 if I make this a cubic graph. So I'm going to make this to the cube, right? So to make that cubic, you hit the shift 6 key to put it up in the power, and then you can type the numbers. So what it's doing, it's taking my graph, shifting it over 5 spots if you can see it.
Are you sure you can put that in?
Yes.
You want me to cover it up?
No, it's free to use.
Okay.
Free use website.
I'm just making sure.
Okay, all right.
Just making sure.
Now, does everyone understand how the horizontal shift works? Look how that works. Horizontal shifting, you either add or subtract inside the parenthesis. So if I want, I could type, instead of -5, I could type in plus, it'll move it to the left then. It's completely opposite what you think it would do. Okay, questions on the first one?
No.
Okay, that's shifting. Let's talk about stretching or shrinking. This one we didn't talk about too much yesterday. Let's talk about how to stretch it vertically. Y equals, I'm talking the x cubed graph. Now, what we do is if you put a number out front, like 2, it'll stretch it vertically taller. So if it normally hit, 1, 1, now it's hitting, here's 1, 1. If it normally hit 1, 1, now it's hitting 1, 2. It's literally twice as tall at the same x coordinate because I put a 2 out front. If I want to make it smaller, shorter, what you do is instead of putting a number out front, you put a fraction out front. Let's say like 1 divided by 3. 1 divided by 3. If you put that out front of the x squared, it will make it 1/3 as tall. So this is normally 1, 1. Now it's hitting 1, 1/3. It's hitting 1/3 the height at that new spot. Okay, that's if you put them out front. If you put them inside the parenthesis, it's completely backwards. Now this is the goofy part. If I type it inside the parenthesis with the x cubed, so 1 divided by 3, I'm going to put the x, close the parenthesis off, and now put it to the cube. So I'm putting the cube, so the 1/3 is inside the parenthesis with the x before you cube it. If you put a fraction on the inside, what we talked about yesterday, it stretches it.
No.
It doesn't shrink it. It's opposite what you think it would do inside the parenthesis. It is literally horizontally 3 times further away. So normally it hits 1, 1. Now it's hitting 3, 1. It's 3 times further from the y-axis. Same heights, the horizontal's been shifted. If you put a whole number out front of the x, let's say like a 4, it'll shrink the picture 1/4. So normally I hit 1, 1. Now I'm hitting 1 at 1/4. It's 1/4 the distance what it normally do. Because you put a whole number in front. It's completely backwards what you think it would do. Okay, questions with the shrinking and stretching. Horizontally versus vertically.
No.
Reflections. If you put a negative sign out front of the x cubed, not in the parenthesis, I'm gonna turn these others off. So if I put a negative sign out front, it will flip it across the x-axis. So normally it's going this way in red. Now it's going the opposite direction. If you put the negative sign on the inside of the parenthesis, I'm going to put it inside the parenthesis now. Now what it's doing is it looks like it did the same thing, but it's not. It's actually going across the y-axis. This is the hard one. I can't really show this. That when you put a negative sign inside, it's actually going across the y, not the x. It's not going down. It's going across this way. If I had something that was asymmetrical, it would probably look better. You'd probably see the difference there.
Yeah, I don't see that.
Yeah, it looks the same.
Let's see. Let's see if I can give you an asymmetrical drawing. X cubed plus x squared. Okay, this.
Whoa.
Okay, so this is asymmetrical. I'm mixing two different powers together. So now what I'm going to do here is to go across the y-axis wherever there's x's. I'm going to put a negative sign on the inside wherever there's x's. So that's cubed plus inside the parenthesis a negative x squared. And so what it's doing is it's going across the y-axis now. If you can see that.
Yeah.
Negative signs on the inside go across the y, negative signs on the outside go across the x. So there's a difference. It's better if you can see it with asymmetrical stuff. Okay, now, last thing. How do I shift this thing up or down?
You just throw it over all that.
Add a number out front, right? So if I want to take the original graph here and shift it up 3, let's say. All you have to do is type in the original thing that you had, x cubed plus x squared, and then all I have to do is add something out back. Let's add a 3. It shifts it up 3 spots. So I've got to put an equal sign. Hold on. Boom. It takes my original graph, goes up 3 from there. Those are the different types of transformations. You can mix and match, but if I type all this stuff in, it will follow this order of operations for how to do it. So if you want to horizontally shift it, stretch or shrink, reflect, and vertical shift, you just add those pieces where you think they should go, and it will go in this order for how it's going to first originally draw it. It'll shift it, it'll stretch from that spot, then it will reflect it from that spot, and then it will vertically move it. So you have to think about the order it's going in so that you actually hit the right location. Now the reason why I'm having you look at this, because the book is going to give you a bunch of graphs and ask you, what did they do to this graph? Did they shift it up? Did they go down? Did they go right, left? You can look at the formula in the graph and see what they're doing.
Won't it be like obvious though?
It should be super obvious. Okay, I just want you getting used to like how those things look. Okay? All right, let's go to the next part here. I only got 2 more examples I want to cover today. As I said, it was a pretty straightforward, easy day. I want to talk about composite one more time, and then talk about evens and odds function if they ask you if it's symmetrical. Okay, so composite functions. Let's go g of x, 5 minus x. So let's say that these are my functions, right? And I want to find f of g of 2. You find the g function with 2 plugged into it. So I'd plug 2 in here.
Great.
So that'd be 5 minus 2, which is 3. So that would replace the g of 2.
Yep.
This 3 would replace it because that's plugging 2 in here, solving it. And then this 3 I'd plug in here. So my final answer would be 3 times 3 plus 2, which my final answer would be 11. They're going to have you evaluate composite functions. And also, if you could tell, like if they did something like this, they might ask, what was your original function and how is it composite? Well, the original function might be this. Maybe f of x was x plus 2, and g of x was x cubed. And their question is, what is the composite function? Well, it's doing this. Like they're asking like what made the composite? These are the parts that made it. Because they took G, plugged it into F, and do you agree that that's what it would make? They're just trying to get you used to like how do I take one item and plug it into others? What would the formula eventually look like? Any questions with composites? Now there's one composite function we have not discussed. It's really not a composite function in general. It's just this concept that I haven't explained since pre-calc days. It's this. And I don't know if I've really reviewed this with you since chapter 1 of pre-calc. What does this actually mean?
Inverse.
Inverse function. You're absolutely right. An inverse function is basically, this is my original function. An inverse is where they take the x and y and they switch their locations. They literally switch the x and y's, and then they resolve for y. That's what an inverse means. So that means I would be subtracting the 2 over, right? You'd move the 2 over, divide by 3, and this function, what you're seeing here is that part. It's the inverse. It's the complete opposite operation. It's undoing what the original one did. Questions on what an inverse is? That was something that was in the book. I don't think they even ask any questions on the homework, but it was something that they brought up, like it is a type of composite in theory. They would just undo each other. All right, last thing, symmetrical, evens versus odds. I'm going to give you an example on the board, and I want to know if it's even or odd symmetry, and why. Why? Good. This is an odd symmetrical function. If we were to go to Desmos and graph this, it would actually be symmetrical. It would be odd, because you're absolutely right. The powers on all the variables are odd numbers. That's what makes it an odd function. If there's a mixed bag of evens and odds, it'd be asymmetrical. It would not be symmetrical in the first place. So you look at the powers, that gives it away. Questions on evens versus odds. Okay, homework's on the board. Page 26, it's due on Friday. It's stupidly simple. It's way easier than I feel the last 2 assignments were.
That's good.
You say that and then I feel dumb.
I mean, if it really
I have a condition that disabled student in calculus homework.
I don't.
I have a condition using that excuse. So, yeah, actually. Nice, it was over there. I think you could.
That's the one, huh?
When I walked into the camera, it was sitting on the phone. I go, sitting over here.
We're not broken.
Yeah, it's probably starting off.
I got you, Alexia.
Whoa. Maybe one, yes. Maybe somebody wants to do it.
I want you to go forward. I don't understand the first question.
Plant banana.
I don't know what it's asking of.